everybody. In this video, I'm going to talk about all things SAT Math Trigonometry. I was able to get a 780 on SAT Math, and in this video, I'm going to go through several different types of problems that you will see on SAT Day involving trigonometry. This is a pretty large portion of the exam, so you want to be confident with it. I'll talk about some of the formulas you need to make sure you know, some of the quick tricks to help you solve problems that you might not be as familiar with, and help you easily use trigonometry, sines, cosine, some radians on SAT Day. So if that's what you need, let's go ahead and jump in. So before I go into the problems that I've handpicked to discuss regarding trigonometry, I just want you to remember that this particular formula right here, sine squared theta plus cosine squared theta, where thetas are the same, equals 1. So keep that in mind. If you square the cosine of an angle and then add the cosine squared of that same angle, then that's always going to equal 1. Just as a quick review, when you have trigonometry, you're going to have an axis like this, and you're going to have 0 degrees over here, 90 degrees up here. That's called a right angle. You're going to have 180 degrees over here and 270 degrees down here. And when you have radians, you're going to have 0 pi here, 1/2 pi over here, pi over here, and 3/2 pi below. And you can convert back and forth between the two. You have degrees and a radian setting on your calculator. So when you have an angle, you might have something like this. You have 30 degrees. And any line, you can see this is a line right here. There's 180 degrees. You have a square. Then you have 4 corners, all made up of 90 degrees. In a circle, you have 360 degrees, like in that, for example. And if you have 2 lines that cross, the angle here is going to be equal to the angle here. And then if you have, say, the angle here and the angle here, those are going to add up to equal 180 degrees because they end up being a straight line. So keep those things in mind when you're solving the problem. When you are solving using radians, you're typically going to have like something like that, and you're going to have coordinates, say 1/2 and square root of 3/2. That would be equal to 60 degrees. And so remember that as you're solving as well. So let's go ahead and get into these problems now. Okay, what is the value of the sine 42 pi? So you can do this 2 ways. You can plug it quickly into your calculator, or you can solve it by hand. You can actually solve it faster by hand if you just know basic formulas. I'll go ahead and solve it for you both ways. If you solve it by hand, you know this is a problem regarding radians, because instead of having degrees next to the sine, you have pi, which means it's radians. As I already mentioned, in 180 degrees, you have a single pi, right? So that means in 360 degrees, that equals 2 pi. Well, you can notice that 42 pi is divisible by 2 pi. In fact, 21 times. Because 2 pi is one circle, you're going around this 22 times, but you're still going to end up right back here at the 0 mark. So sine of 42 pi in reality actually equals the sine of 0 pi. So now that you figure out how to simplify the problem, you can figure out what is the sine of 0 pi. Well, the sine is always going to be the y-coordinate of this point. The cosine is always going to be the x-coordinate. It's easy because when you have 0 degrees or 0 pi, the y-coordinate is always going to be equal to 0. So sine of 42 pi equals 0. And in the unit circle like this, your cosine would always be equal to, or cosine of 42 pi is equal to 1. But they're asking us for the sine here, so our answer is going to be A. It's going to be equal to 1. Now let me go ahead and quickly show you how to solve this on the calculator. So here we have Desmos graphing calculator. If you weren't using a graphing calculator, you're just using your regular scientific calculator, you could also solve it using this problem using radians mode or by converting the radians into degrees. But since you'll have access to Desmos on SAT Day, I'm going to go ahead and show you using this. So let's go ahead and plug in our problem. It's very quick here, 42 pi, 0. So there's a confirmation, our answer is correct. All right, so now that we've solved that, we can go ahead and move on. In triangle XYZ, angle Y is a right angle. Point P lies on XYZ. Okay, so let's go ahead and mark this out. Y is a right angle, so we have Y. You have X, and you have Z. Angle Y is a right angle. Point P lies on XZ. You have XZ right here. So point P is going to lie some point on here. Point P. And point Q lies on YZ, such that PQ is parallel to XY. So you're going to have something like that, such that these two are parallel to each other. If the measure of angle XZY is 63 degrees, so it's going to mean that's going to be 63 degrees. What is the measure in degrees of angle XPQ? So what is that? So it's going to help us to realize that you actually have two triangles here. You have triangle XYZ and you have triangle PQZ, which are similar to each other. So you can see that you have a smaller little right angle there. And all your angles in a triangle add up to always be 180 degrees. So that means that YXZ plus XYZ plus XZY all equal 180 degrees. That also means that angle PQZ plus angle QPZ plus angle PZQ equal 180 degrees. So we already know that this angle here is going to be 90 degrees. We know that this angle here is going to be 63 degrees. So that means our remaining angle, let's call it angle X, adding those all up together, you're going to have 180 degrees. So at this point, you can just solve using basic algebra skills, right? You have 90 minus 63 degrees in the end. I'm shorthanding a little bit here, equals 27 degrees. So that's going to be what angle X equals. But we can't stop there because you remember, 27 degrees is only the measurement of that. The other side is what we're really trying to solve for. But as I already mentioned, you have a straight line here, and straight lines degrees always add up to be 180. So because one side of the angle is 27 degrees, then your other side is going to be 180 minus 27, which is 153 degrees. So that's going to be your answer. Okay, which of the following expressions is equivalent to sine of 24 times cosine of 66 plus the cosine of 24 times sine of 66? So the important thing to recognize here is that you have complementary angles. What that means is that 24 degrees plus 66 degrees equals 90 degrees, which is a right angle. So if you have a line, let's pretend this is the x-axis, or that's the y-axis, this is the x-axis, and here's our origin. You have the sine of 24, or 24 degrees, which is going to be approximately over here, and you have the cosine of 66, going to be approximately over here. The sine in complementary angles, because both the angles I put together end up adding up to 90 degrees, your x-coordinate here is actually going to equal your y-coordinate here. And your y-coordinate here is actually going to equal your x-coordinate here, which means that sine of 24 degrees equals cosine of 66 degrees. And the sine of 66 degrees equals cosine of 24 degrees. Right, so that's the key thing to know here with our complementary angles. So using that, we should be able to, or that idea, we should be able to pretty easily solve this problem. Does this expression up here equal expression A? Well, it doesn't appear so, or based on the information that we have. There's no clear, it's not clear that you can immediately substitute, say, the cosine of 66 in for the sine of 24 in order to get this out. And I would say the same thing for B. But if you look at equation C, you can see that this would make sense because if you substituted cosine of 66 in for sine of 24, you would have something like this. Cosine of 66 degrees times cosine 66 degrees. And then if you substituted cosine of 24 degrees in here, you would have the cosine 24 degrees plus the cosine of 24 degrees, which equals cosine of 66 squared plus cosine of 24 squared. It relies on substitution. And it's actually pretty easy to see. You can play around with problems A, B, and D, and it's not immediately apparent when you look at them why that equation doesn't equal the one above. But once you reach equation C, it's pretty quick to understand why that is equal to the original problem given. If this seems a little bit difficult, you always can plug this portion of the problem into a calculator and see what the value is, and then do the same thing for A, B, C, D, and D until you get numbers that equal each other. However, that takes more time, and if you're at a crunch, it's definitely easier to use this method, and you're also likely to accidentally manually mess up one of the numbers when you put it in the calculator because there's so many numbers being thrown around here, to forget a parenthesis, that kind of thing. And so it's really a lot faster to remember that complementary angles here, and you can just substitute like sine of 24 out for the cosine of 66, or vice versa, instead of using a regular calculator. If you enjoyed this video, please like and subscribe. This is a part of my college applications, and you can help me out by engaging with my channel and helping me improve my college applications for this fall. If you need more SAT related content, you can find tons of that on my channel, whether it's SAT Math, like geometry, math tricks, SAT reading and writing, or college applications, even in general. So I hope you enjoyed this video. If you have any requests for future videos, please feel free to leave those in the comments below, because I will make videos to your request. But anyway, that said, I hope you have a great next SAT, and good luck.